So now that we've seen how to create a very basic OSGi bundle, let's go ahead and get into more of the details of what is a bundle and what are the things that can go inside of it. So starting off, let's talk a little bit more about the bundle or our OSGi bundles. First and foremost, every bundle has a way of being uniquely identified, and the way that's done is through the manifest file. Inside of the manifest file, there's going to be two headers. One is called the bundle symbolic name, and the other one is called the bundle version. So the symbolic name and the version numbers all completely up to us as to what we want to put there. So those are the two things that are needed to uniquely identify a bundle. In doing so, multiple versions of the same bundle as well as the same library can exist inside the OSGi container, so long as those two things are different. Now, when we are creating different versions of our OSGi bundles, we're using semantic versioning. So typically you'll see at least 3 placeholders, but sometimes you'll see this fourth one here. So major, minor, micro, followed by the qualifier. The qualifier is the one that you may sometimes see. So let's talk about what each one kind of does. So we'll start from the bottom and then we'll go up. So starting with the qualifier, that attribute actually has no real impact in regards to the version number. This is just a way to be able to kind of further distinguish our version numbers. So for example, maybe we are in beta and we want to say that. So there's no distinct way to numerically say we're in beta. We can use the qualifier to say, 1.0.0-beta, for example. So that's what the qualifier does. It doesn't really have any strong impact. It is just that, a qualifier, or kind of a way to distinguish. We go up from there and then we have micro. Micro is a very small change that doesn't affect the API. Right. So most of the time when we see a change in micro, there's not going to be any sort of compatibility issues. It's very backwards compatible up and down. When we go up to minor, this is when a change in the API can occur. Now typically this isn't going to be a breaking change, so there's still some backwards compatibility, but be wary, be cautious that the API probably did change along the way. And so check out documentation to see what those changes may be and how it may or may not affect you. And then finally, the major, this is the breaking change in the API that says, once we hit that major change, backwards compatibility is probably out the window. It's not going to happen. So for more details there is that link for semantic versioning and all of the fun stuff that has to offer. We bring up semantic versioning because we have the ability to control what versions of bundles we may use. So the two primary ways we have are square brackets to show that this is inclusive, and parentheses to show this is exclusive. So for example, we see here on the last bullet point, the bracket followed by 1.1. So this says I can use version 1.1. It is included all the way up to 2.0. Since we see the parentheses at the end, it's up to 2.0, but 2.0 is not included. It is excluded. So we have that sort of control to say include this, but exclude that, whatever this and that may be. So for example here, we can have two bundles, right, distinguishing their specific version numbers. So over here in bundle number 1, it is exporting a specific package with a specific version number. Down here on bundle number 2, we are importing a package and we're saying, when I'm importing this package, I need a version number that is including 1.2 all the way up to 2.0, but excluding 2.0. So from 1.2 up to 2.0, but not including 2.0. So pretty simple, right? So that is version numbering, and the way that versioning is kind of controlled within the OSGi world using semantic versioning, as it's called. The next thing in the world of bundles is the bundle lifecycle. So first is the versioning of the bundles cycle. So the bundle lifecycle is controlled using this thing called an activator. The activator allows us to kind of tap into the bundle's lifecycle as the bundle traverses through different phases of its lifecycle. There are specific methods that correspond with it. As those methods are called, we can then do something within it. So for example, in the code that we see here, when the bundle starts up, we print up hello world. When the bundle stops, we print out goodbye world. So that's what's going on there. So the bundle activator helps the bundle traverse through its life cycle. And we'll take a look at some of the logistics of that a little later, and how we're not really going to use it all too much. But in any case, the bundle lifecycle itself has 6 different phases. Of those 6, we really emphasize 3 of them, but let's go ahead and cover each one of these different lifecycle phases. So this diagram here gives us a very good illustration of how the bundle lifecycle works kind of from start to finish. So first things first is once we have the bundle and we deploy the bundle into the OSGi container, it's going to reach its first state once inside the container, known as installed. So the installed state just means we are inside the OSGi container. Nothing more, nothing less. We usually don't stay here for very long. During the installed state, what the bundle is trying to do is resolve its dependencies. So we saw how we can export and import bundles, or packages I should say. If we are importing a specific package, it's during the installed state that the OSGi container is trying to get that package imported. Now once all of our dependencies are finished up, we then reach the next state. This is going to be the resolve state. Now the resolve state is also a good state to be in. What this means is that all of the dependencies that the bundle needs has been met. They've been resolved. But that's it. It doesn't mean anything more, anything less. So though the resolve state is a good indicator, that's not the final step. From the resolve state, we want to start the bundle. We want it to do whatever it is that it's designed to do. So in order for it to function, it needs to be started up. So from the resolve state, we hit a transition state called starting. And then from starting, we then go to the next state, active. Once the bundle is in the active state, this is the final stop. This is where we want to be. It's here in the active state that whatever we've designed the bundle to do, it should be doing it, assuming all of our code is correct. But let's say it's not, or maybe we need to fix things up a little bit. We can then tell the bundle to stop. It'll then transition from the stopping phase over to the resolved phase. So resolved phase, again, I'm ready to go. My dependencies have been met. I'm just waiting for someone to tell me to start. And then finally, we can always uninstall a bundle from the OSGi container. So the 3 big phases that we really focus in on is installed, resolved, and active. So it's nice to know these 3 big phases as well as the whole bundle lifecycle. But of course, the big question is, well, how do I know this, right? How do I know when a bundle is in a specific lifecycle phase? And lucky for us, there's a couple of tools that are going to help us out. So let's talk about those tools. So the first tool is known as the Apache Felix Gogo shell. Apache Felix Gogo is a subproject of Apache Felix, and the Gogo shell itself is a tool that's used to be able to look inside of the OSGi container. Right, so it is a command line based tool. So it's very simple, very easy to use. So accessing the Go shell is actually pretty easy. When we ran our OSGi bundle over in the previous exercise, it actually brought us over to the Go shell. So we'll be taking a look at that pretty soon. But one of the most common commands that we're going to be using in the Go shell is lb. lb allows us to take a look at all of the bundles that are inside the OSGi framework or the OSGi container. And so we're going to be taking a look at that pretty soon. So we know the big phases. We know how to look at them, right, using that lb command in the Go shell. But how do we manage the life cycle? It's good to know, but if we don't know what to do after that, right, we're kind of left in the dark. So the Go shell also provides a number of different commands that can help us transition between one OSGi lifecycle phase to another. So the list is here. The big ones that we will use is start and stop, but keep note of the other ones as well. In this diagram over here, we see how each one of those commands kind of helps us out. We can use the install command to do just that. Install an OSGi bundle, get it to the installed state. Maybe some of the dependencies are not met, and so we can refresh and update once we try to meet them, so that hopefully we transition from one state to another. Or maybe vice versa, right? Maybe the bundle is in the resolve state, but we introduce something that makes it installed, but it doesn't update right away. So when we update and refresh, maybe we might see that as well. When a bundle is resolved, we ourselves can manually start it using the start command. And then you can also manually stop it using the stop command. So very simple, very straightforward there. And finally, we can always uninstall the the bundles using the uninstall command. So in the next exercise, what we're going to do is just really simply start, stop, and take a look at the bundle's state. So let's go ahead and take a look at that.